So let's go to the next data structure. This is so-called dictionaries. Until now, we had the lists and the tuples as container types, and they were basically containing elements in a certain order. If you wanted to access a given element, you had to know at which position it was. So basically, we were accessing the elements by their position. Dictionaries are a little bit different in the sense that we can access elements by a so-called key. So basically, as you see here the example, we are creating a dictionary with some items. I am putting, let's say, the item 1, the item hello, and this list, for example, in the dictionary. But instead of having positions, I am associating each item with a given key. So let's do that in our worksheet. I am basically here going to the end of the worksheet chapter 3, and let's just create a dictionary. We will just call it DT, for example, like a dictionary, and I will have, let's say, a key. Let's call it key 1 and associate with the value. Then I have a key 2, again a string, associating with a completely different value, let's say with 3 points. I'm the floating point number, or I will have just another key which can be also a number, for example 4, and associating with a value string hello. So let's execute and have a look what D is. This DD is, and you see this is here basically a collection of items. The key 4, the number 4, is associated with the item hello. The key with the, which is a string key 1, is associated with the value with the item 12, and key 3, the string key 2, sorry, is associated here with the item 3.5. So this is completely different to that what we had before, and if you look at that, even the order is different. I was specifying them in those order, but here the order is different, and this is very typical for dictionaries and also sets, which we'll cover soon, is that they are so-called unordered data sets. That means the order of the elements is not specified. The only thing which is specified, which key gives me which element. Actually, if you are using newer Python versions, it can turn out that they are ordered indeed. In the newer Python versions, dictionaries are so-called ordered dictionaries. So you get the elements in the same order listed as you have entered in the dictionary. But nevertheless, the main thing in dictionaries is that you can associate keys with the elements. Now, if you want to access those keys, you are doing the same as before with the square braces. However, instead of giving a position, you could try to give a position. Let's say we could say let that give me the second element, which would be the last one, and you get basically key error because it's not contained. So the elements are not stored by position. The elements are associated here with keys. So basically, if I wanted to have this this value, this 3.5, then I would have to enter in this square brace actually the key 2, the string key 2, and then it works. What can be a key? Key can be anything which is unmutable. That means it can be numbers, it can be booleans, but also it can be strings, and of course it can be tuples. So tuples are unmutable, and therefore they can be used as keys in dictionaries. Okay. So this is exactly what we covered here. The dictionaries are mutable, similar to lists. They are mutable. That means you can basically change them after they have been created. What does it mean? You can just override the content of a given entry or create a new entry. So basically I had DD key 2 that was associated with 3.5, but instead of that I can replace it, let's say, with 1 plus 2j, with the complex number 1 plus 2j, and if I execute it, you see that the dictionary changed, and indeed the key 2, the key with which was the string key 2, is now associated with the new number. If you just have a dictionary enter a key which it doesn't exist, let's say no, I'm using a tuple, I didn't use tuple as key now, and I will just use a tuple with a content -1 and I will associate tuple 1 as a string, so basically that will be the value. And if we now look at the DD, and if we look at this dictionary, we see that exactly here the key -1 has been created, and it was associated with the value tuple 1. And of course, if you want to basically have this thing, so access this thing, then you have to use the right key, and then you get exactly the value which you entered back. You can also delete elements from the dictionaries, and that works similar as for the list with the del operator. And then the only difference is that here in the square braces you have to indicate the key instead of the position. So if I want to delete the element with the key -1 then I say del dd -1 and if I now have a look at dd, indeed this first this my element in this by -1 indeed disappeared, including its value, of course. So this is how dictionaries works. Empty dictionary is very consistent how it's listed with tuples. Empty dictionary is the one which you just make a curly brace opening and closing, and that's basically then empty dictionary. The length, the number of items in a dictionary you can get with the len, right? So basically dictionaries are very similar to that, what we learned about lists. The big difference is, as I said, first of all, the semantic difference. You are using curly braces instead of square braces, and instead of having positions, elements identified by their position, you have elements identified by their key, and here this column here in order to separate key from value. And when you have a key value pair, then here a comma is indicating that the next key value pair is coming, right? And then otherwise many things are similar to lists, because this is also a container. You can, for example, similar to lists, check for containment. However, for dictionaries, containment means whether a certain key is present of a dictionary, right? So if you have here dd, this is now empty, we were overwriting it, so I will just go back to the original definition and define my dictionary again. Let's make a copy paste. So I'm just copying it here with Ctrl C, and here inserting it with Ctrl V, and then I'm executing it again. And now let's check whether for example key 1, the string key 1 is in dd, and then the answer is yes. However, the containment always refers to the key, not to the value. So if I'm checking whether 12 is in the dictionary, then the answer is false. Why? Because 12 is a value, not a key. Okay, so the in checks whether a given key is present in the dictionary. If you want to access an element in the dictionary and let's say print it out, so not assign but basically access and read it out, then of course, as we discussed, you have to enter here in the square braces basically the position. Instead of position, you are entering the key. Now if you try to access something which is not there, let's say key 3, the string key 3 doesn't occur a key, then of course you get an error message because it doesn't exist. There is also a smooth way of getting elements if you are not sure whether an element is there or not, but if it's there, you would like to have its value. If it's not there, you would like to have a default value, then you can use the so-called get method of the dictionary. So you write a dictionary, which is in our case a dictionary dd, and get, and I will say key 3, and if it's not found, it should give us let's say the value, the string not present, for example. And now if I execute that, it didn't find key 3, so therefore as a value it gave the string back not present. The key has not been created in a dictionary, so the dictionary still doesn't contain key 3, but it gave us something what we specified as default value back. The default value is actually optional. You can also leave it away, so you can say dd get key 3. Let's say this associated with the value val. And if you know print value, then you see it's none. So basically, if you're not specifying what should be the default here, then it's automatically set to none. And as I said, this get method is quite good if you want to fetch something, and if it's not there, then you want to have a default value instead of an error message. You want to have a default value instead. And if you look at this, this is basically completely equivalent to this kind of logic. So basically it is d0 get key, and default is the same as looking at whether the key is present. If yes, then returning the key, otherwise if not, returning the default value, right? So this is how it works. Then the next data structure, which is very similar to dictionaries, are the so-called sets, which is basically dictionaries but without the keys, so or without the values. Sorry. So basically, think about that the dictionary which contains only keys but no values, and that would be the sets. And so as to say here, see here in the example, basically what we have here is nothing else than the set. And the set contains of just entries, and let's enter that here. I'm just copy pasting to speed it a little bit up. So I say S1 is equal a set with containing those elements, and if you give now out the S1, then you see that basically you have exactly those elements. The order again is not the same. Sets similar to dictionaries are not ordered. The only thing which is for sets interesting, whether a key or an entry is present in the set or not. So basically the most important operation we would have with set is checking whether something is within a set. So you could, for example, say test in S1, and then indeed test is in N1. But if you look whether the string test2 is in N1, then S1, then it will say no, because that's not present in S1. How can you, once you have created a set, sets are also mutable, so you can basically extend them. Extending a set can be by adding an element with the function true. So if we here look at our set 1, this is what we have as elements, and now let's say S1 and add, and for example the logical true. I mean, this is something you can add to a set. And if you look at S1, now you see that basically here it's contained. Set is basically like a dictionary with keys only without values. What does it mean? It means that you have to have only immutable elements as part of the set. So if you try to add a list, for example, to a set, it will not work. It's a so-called unhashable type. That means because it's mutable, it cannot calculate a so-called hash which is needed in order to store it in a set or in a dictionary. So all the sets are elements in the sets are like keys in the dictionary. They must be unmutable objects. Good. So if you want to remove something from a set, then it's basically the remove method of the set. And that's, for example, if you look at our set here and we say s1.remove, and we want to remove this last element which we entered the element true, and if you look at s1, it has been removed. If we also wanted to remove test, the string test from the set, then s1.remove test, and you see that it disappeared. By the way, when I was typing, you have seen probably I'm using always the tabulator, the tab button, the tab key in order to extend things. That also works in the not just in the shell which we have covered, but also in this IPython notebook. So I say s1 dot, and I say re for remove, and I say tab. It's executing automatically, and then with the tab, so you have to type less as usual, always using the tab button. Okay. Good. The in operator we have checked, and this is the most important property of the sets that you can check for comparison. So just to summarize that, the free data types, those will be the free continuous data types that we will deal most of the time are lists, and those are ordered elements. So basically they are identified by their position. Okay, the dictionaries are unordered usually, and the elements are identified by their keys. The values are identified by the keys, and sets are basically also unordered, and there are no values, basically just a collection of keys, and they are also unique. So what is if you want to access a certain element in the list, it's very fast if you know its position. If you don't know the position of the element, that means you have to go through the set and check every element every value one by one, whether it's a given value. Then it's very slow because you have to traverse the entire list. The same with dictionaries. If you know the key of the item, of the value you are looking for, then it's very fast. Basically, it's immediate. However, if you want to iterate and look for all the values, then it's very slow. And sets, of course, it's just a context. It's just a container of keys, and accessing checking the presence of an element in a set is very, very fast, and this is what they are very good for, and this is what we will use them for. Now if you have a container, how can you get out the elements? Of course, if you know that the elements inside, you can just read it out. But very often what you want to do, you just obtain a container and you want to iterate over all the elements and basically process the elements one by one. And this is what you can do in Python. If you remember the last time we had the for loop, which was the for construct, which was basically here. It was a for, you have specified a variable, then the name in, and then you were here on the right hand side, we were specifying things which we can iterate over. It was either a string where we could iterate over the characters, if you remember, or we could specify a range, and then we were basically iterating over the numbers within this range. Now this iteration concept can be generalized, it's much more general. Here you can have basically everything which provides item over which Python can iterate. And of course, if you have a list like here, then of course the items will be which Python will iterate is the items in the list. So let's make an example. Let's make the list LL, and I would say just 1, then here a string. I will just enter a floating point number, and then maybe here, I don't know, a tuple, for example. It doesn't really matter, list can contain everything. And now we can say, okay, let's run the variable item over the list LL. And then let's just print, say, item, and then we are printing the variable item. And if you execute it, this is exactly what happens. The for loop is executed exactly 4 times because the length of the list is 4. And basically in every iteration, it gets the next element of the list. So basically here, the 1, and then the test, the string test, then basically the floating point number 3.4, and so on and so on. So basically this is how you are iterating over the elements of a list. For the sets, is the same. You can also iterate over a given set. Let's take all set S1 and modify the example here. I will just copy it and paste it here. And now we want to iterate over the set S1, and then you get the elements here 1, 2, 12, and minus 3.6. Here you already note that basically the order has changed. Sets are usually unordered, so you should not rely on the order of the elements in the set, but you can get them one by one in a given order if you iterate over them. If you have a dictionary, in a dictionary you have key and values. So basically what if you just normally iterate, then the iteration would be over the keys. So basically, as the example shows you here, if you make an iteration, you get the keys. So let's have a look at that. Here our dictionary is already present, so dd, and now let's say for key in dd, and then we say print key, and then we are printing the variable key, and you see indeed it was basically iterating over all the elements in the dictionary, but all the keys. Now if you want to iterate over values, that's also possible, but then you have to use the values method of the dictionary. That means you could just modify here this loop again. Let's have this loop again, but now I will call it val, and I will not iterate over the dictionaries, but I will call the dictionaries the values method of the dictionary, which would basically give back an object which contains all the values, so that one can iterate over that, and then the result would be the value, and here I'm printing value, and indeed you see we got 12, 3.5, and hello, the string hello back. Those were the values. And if you want to iterate over both keys and values, or the key and value pairs, then you have to use, instead of the values method, the so-called items method of the dictionary. So that will be the last example for this iteration over dictionary. So let's copy paste again this lines here, and instead of values I am writing items, and then let's call the variable not val, because that would be not a right choice. Let's call it item, so it's more clear the intention of what we were to do. And then we will just print item, and then you see what did we get? We got basically a tuple. So in every iteration we got a tuple which contains as first element the key, and then the second element the corresponding value. And of course, this tuple we can then process, and we can even decompose or unpack, as we did already in the before with the tuples. We can unpack it in the for loop, because we always know every tuple will have exactly two elements, one key and the value, and we could just basically modify what was written here, this iteration over the items. But instead of storing the tuple as the variable item, we will just decompose it in the variable key and val, and that will match, because every tuple which is returned by this will has exactly two elements, the key and the value element, and then we can just print them key separately and the value separately, key and then value val separately. And if you enter that, you see, okay, indeed the variable key contains the key 1, the string key 1, which was the first key, and the variable and the value, the variable val was assigned the value 12, which was the corresponding value. So basically this way you can easily iterate over the various elements in the dictionary as well. Sometimes, especially if you iterate over lists, it's very helpful to know at which element you are, which is the position of the element you are at. And this is something you can achieve with the so-called enumerate function in Python. That means if you just mask, let's make an example here. Just make a new cell. If you just have a given list, we had this list LL, and if you just take enumerate LL, and then let's say for item in enumerate LL, and we just print item to see what it does. I mean, this is something you can always do. Then you see that you get basically the elements of the list 1, the string test, 3.4, and so on. But as a part of a tuple, as a second element of the tuple, and the first element of the tuple is always the position, so 0, 1, 2, and 3. So it's a little bit similar to that what we had with the dictionaries, where we get tuples with key and value. Now you get also tuples for the lists with key and value, but the key in the list is, of course, is always the possession. And similar to how we did with the dictionary, we can also decompose that one. So we could say the index of the element and the value of the element is should be the first and the second part of the tuple, and then we can just write print int, and then I will just make a colon and val, so that we see that it works. And you see here the variable int was printed, which was always the index, and then val, which was always the corresponding value. So that's also a way to iterate over the list, and this is equivalent, which I won't type in, as if you would just run over the range of the length of the list. So you would get just the numbers, the positions, and then you would basically query the element at that position in the list. But usually enumerate is faster, which can be important if your list is very big. A further thing I would like to talk with you today in this session is the initialization of the containers. I mean, until now, when we initialize the container, we were just saying, okay, the list is something, and we were entering the elements. But this is not the only way. You can basically convert everything to a list, or everything to a tuple, or let's take those, or to a set, provided Python can iterate over the items of what you provide. So what does it mean? Here you see an example. You could try to convert something, a test, the string test, into the list. So let's see what happens. We just take that string test and convert it to a list, and you see that basically you got a list containing the characters T, E, S, and T. So basically it was iterating, as we know it from the last time. Iterating over a string means that getting its characters one by one, and basically from that it was creating a list. We could also try to create a set from that. What happens if I create a set from that? And you see this is a little bit different. It has only 3 elements, not 4. Why? Because if you iterate over the characters of test, first the character T happens, it's appended to the list, to the set. Then the character E comes, appended to the set. Then the character S appending to the set, and then the character T again, and because T was in the set already, appending the same element to the set, which is already in the set, doesn't change anything because the set already contains that, right? Similar to the keys in a dictionary, which must be unique, also the elements in a set are unique. and therefore you get basically, if you convert a string to a set, you get basically the unique characters, right? So which characters are there, but basically characters are not counted twice because an element can be only once a part of a list. So that was this example here. You can of course also instead of a string, you can also pass a list, for example. So if you want to make a set with a certain given entries, let's say, then you can pass it as a list, and then it will be immediately converted to a set. It's not a list because you see here, maybe not that easy to see, but you see here that those are curly braces, right? If you want to get a dictionary, contains always key value pairs, so you can also have a dictionary from a list, but the list must contain tuples, and each tuple must contain a key and a value. So let's say key 1 and 1, and then here another tuple, let's call it just a string key 2 and 2, and if you execute that, you see that you get a dictionary where basically key 1 is the first key associated with the value 1, which was the second element in the first tuple, and so on. So basically dictionaries need something which when they are created, which contains tuples, and each tuple has two elements. One is the key and one is the corresponding value. Good. So the next thing I would like to have a look at that is the so-called list comprehensions and dictionary comprehensions or set comprehension, depending for which object type you are applying it. And that's how to create lists for even more compact than before. And let's assume first, let's have a list which we will call words. And these words should contain a few strings, like what, word, and words. For example, those 4 entries. And now I would like to create a list which contains the same words but converted all of them to lowercase. So that will be the next exercise. In order to convert something to lowercase, let's take an example. Let's assume I have a string which is called word. Okay. And then if I want to convert it to lowercase, I can apply the method lower to the string. Strings are immutable, so it will not convert the string itself to lowercase, but it will return a new string which is the same string as before, but everything convert to lowercase, right? And now I want to apply to all elements in this list, and that theoretically with everything which we have learned so far, we could just make, let's say, words lower. That would be the list of words with lowercase. First I make an empty list, it doesn't contain anything. Then I make a list, a loop for word with the variable word in. It should run over the list of words which was contained in the variable words, and then we should words lower append just word dot lower. What does it mean? I just take the variable word which contains the entries in the list word, and I just call to for each of them the lower method, which gives me a new string with the same content but convert to lowercase, and this I would append basically to the list words lower. And if I execute that and I look on the list words lower, then you see that it contains exactly the same thing but converted to lowercase. Now this is a little bit long, and it turns out you can simplify that in Python quite a lot, and which always works if you have a simple for loop which creates a list. And we could, instead of say words lower is equal, what do I need? I need word dot lower. So basically the lower value of word for, and now I have to write a loop word in words. So what does it mean? Well, let's see whether it works. Yeah, it works. And if I give the value out of words lower, then it's indeed the right list. So what does it mean? Run with the variable word over every entries in words and convert them the value of the variable word, convert it to lowercase, so create a new string which is lowercase, and all the entries which you get that way basically combine them into a list. So this is so-called list comprehension. And this is very handy for cases where you have very easy list creation operations. If it's complicated, if you need many operations or something complicated here, complicated expression here, then you should not do it this way because it will be very hard to read. But if the expression is trivial, like here, just converting lowercase, it's a very, very nice notation. Actually, as it is shown on the slide, you can even add an if you want a condition. So basically skip or filter out some of the entries. And basically the example which we have here is, let's say we create no numbers, 1, 3, 4, 9, 12, doesn't really matter which kind of numbers, 8, let's say 25, okay. And let's assume I want to create a list which contains the square of those entries. So I could say squares. I can now use my list comprehension as we learned it. So basically I will just type, I will say I need the square of a number, num to the square, for so that means for num running over nums. And then the squares, I will get the square of all numbers. Now let's assume I want to get only the square of those numbers in this list nums, which are even or which are odd, for example. So I would say if num, how do I specify that a number is odd in Python? I just take the remainder by division by 2. If it's 0, the division is 2, is 0, then it's even, but we know that 0 is interpreted as false, so they were not included. And if this remainder is 1, which means it's non-zero, it will be interpreted in Python as true, and therefore they will be included. So basically in these for loops, only the entries will be included for those the if statements gives true. And if you have a look at that and execute again, you see that only the power of the square of 1, of 9, and 25 had been included. But as I said, you use those constructs carefully. If the if, for example, only if the if statement here, if expression, it's a very trivial one. If it's a complicated one, then use an explicit loop as we did it before, and then you can add an if inside. So let's have a look how you would have done it if you do it by hand. You could have said that squares is equal the empty list, and then you could have said for num in nums, just making a for loop, and then we would have said if num %2. So basically if it's not if the remainder is non-zero, so it's if it's an odd number, then you could have said okay, sqrs dot append num to the square. And then if you look at sqrs, it's exactly the same. So basically what we were writing here, it's a very, very nice handy notation, which basically one single line instead of these 4 lines, and this is even Python sometimes even faster, considerably faster than writing those 4 lines. But please only do that. The most important thing is that your code is readable. Only do that if the expressions which are appearing here are short and trivial. Okay, so we are almost finished. We can do the same comprehension also for sets. So basically exactly what we did here above with the list. We could do it with a set, with the differences that I am enclosing it in curly braces, and then the result. Oh, my Python or the Python notebook just automatically inserted something here. So it's curly braces instead of the square brackets, and then you see that basically here you have the same, but here as a list, right? As a set, sorry. And if I apply it, for example, to the words. Here we had this comprehension with the words. Let's have a look at that. I would like to do it the same. So let's have a look at words first. Then let's take the same comprehension. But no, I will, instead of making a list, I will make here a set. And if you look at words lower, what do you see? You see that I have only 2 entries. Why? Because basically here we know that in a set only unique entries can be. So basically word converted to lowercase word was the same as that here and that here. So basically I get the 2 unique entries here. So that is all very handy if you want to sort out duplicates, for example, from a list and so on. And if you want to create a dictionary for whatever reasons, then you can also make a list, a dictionary comprehension exactly with the same syntax as before. However, you have to provide a key value pair. So basically, going back to the examples with the numbers, here we had it as a list. Again, we can also create a dictionary on the fly, but then we would have to say what should be the key and what should be the value. I could, for example, take the key as the number itself as a value. I could take the square, and then squares would be a dictionary which for every entry, for every key, which is the number, contains here the square. And again, because of the if, only the odd numbers had been squared. So that's very, very helpful. But as I said, I would like to ask you only use that if it's really small enough and short enough, the expression, so that your code stays readable. The next thing I would like to cover is how to compare, or what happens if you are comparing dictionaries, lists, or sets with each other. And containers can be, of course, compared, and they are equal if they are containing exactly the same items, right? And for lists, it means it contains the elements exactly in the same, or the same elements in the same order. In set, it means it contains the same elements, and for dictionary, it contains the same case and element pairs within. And those sets which are so-called ordered sets can be even looked at whether they are smaller or bigger. You see here, for example, a tuple or a list is also an ordered structure, and then the comparison will happen basically element by element. What does it mean? That basically they are looking at the first item. If they are compared, if the question is whether 9, or let's look at maybe at this example. That's a better example to start with. Let's say we are saying 1, 2, and 3, whether this tuple is bigger than 1, 2, and 4, and let's do 1, 2, and minus 1, and the answer is true. And the question is why. It compares the first element in the list in the tuple and with the first element in the other tuple, and it seems that it cannot be decided. So it goes to the second element, and they are also the same, so it cannot decide it whether they are bigger or not. And then it goes to the third element. This is 3 here and minus 1 here. No, it can be decided 3 is bigger than minus 1, so the value is true. If I change the last element to 4, then it will be false, right? But for example, if it already had been decided at the first element, let's say I'm just changing here that one to minus 1, then you see that it's immediately saying true, because 1 is bigger than minus 1, and then no other elements are investigated. So basically with the ordered lists and the ordered structures like lists and tuples, basically comparing whether it's bigger or smaller means that element wise compare until it's you can decide it, and the very first time when it can be decided, then that's basically the value of the comparison, and basically it's the comparison is stopped. Of course, if you have something unordered, then it's very difficult to compare. So for example, if I have a dictionary with 1 and the string hello, and I'm asking whether it's bigger than another dictionary which has the key, only the key 2 and the string hello 2, and if you try to compare, of course, equal, greater, less, and so on is not supported, because you cannot compare because they are unordered. But you can, however, check whether they are the same, because that can be easily decided, or whether they are unequal. That can be also easily decided, but there is no way to compare whether it's smaller or bigger. And the nice thing is why the ordering the here is important or interesting with the comparison of ordered sets is that you can have it you can use it in a sort function. So let's have a look. You have a here a list which contains tuples. Let's say here, let's say 9 and ahoy, the string ahoy, and let's say 2 and the string Zulu. So L1 is a list. Sorry, LL. That's a typo here. LL is this list which I just entered. Okay. And now what happens if I want to sort it? Then basically it will sort it element by element. So basically this or compare the elements with each other. What happens if I'm comparing the elements 9 ahoy is less than 2 and Zulu? What would happen? Of course, in the comparison, it will take the first entry from the order set. This is 9, and the question is 9 less than 2? No, that's not the case. So basically, it will be false. So basically, 9 is bigger. So, and then basically the second thing, although it starts with an A and this is the Z, it will be not investigated anymore, because as soon as the comparison has been decided, it will automatically stop. So basically, with that knowledge, we could already guess what happens if we are taking LL and sorting it. So basically, we said LL sort, and then we want to have a look at the value of LL, and you see basically it will exchanging it because it was based on the first number. So if you have tuples, for example, words, and let's say the number of occurrences, how often a certain word occurred in a test, and you have it in a list and you sort it, then basically you will have automatically it in the right order, because the small numbers, the small occurrence will occur first, and then because the first, based on the first number in each tuple, it can be already decided, the order can be already decided. The second element won't be investigated at all, it's just included accordingly. Okay, good. So the last thing I want to finish this session is last two slides for this session are string methods, and the one thing I want to discuss with you is splitting and joining strings, and this is a very handy method. For example, if you have a string of words, let's say the user just entered some text with words. This is basically, let's say, the input which the user entered, and you want to analyze this input for word by word, so you want to decompose that into words. Then in Python there is every string has a so-called split method, and if you call the split method, then basically the text, the string, will be splitted into a list of strings, and every element in this list is a word. So basically all the white spaces from the text are removed. Also, if you have a new line here, there, and here second line, then here this is with a new line character. If you remember for last time, if you just split it, basically the new line is also considered as a white space. So basically you get just the words, the tokens from this text. If you want to split with respect of something else than the white space, then you can just specify it as a parameter to the split function. So for example, if you have let's say the string A, B, C, and D, so basically all here just separated by commas, then you can just specify that I would like to split it by the commas, and then you get a list of with the entries which were separated by commas. If you would leave away basically this comma, then it will separate by white spaces, and because this string didn't contain any white spaces, you would get just one entry. And then of course the vice versa, if you can split, you should be also able to join, and that's exactly the case. Let's do it properly here. I will just call it the variables entries, and let's have a look at entries. This is exactly this list, and if I want to get back the original one, then I can just take the comma dot join. So basically join, and the join I have to pass a list which contains of strings, and then those strings will be joined by the character which is indicated here, right? And then you get A, B, C, D separated by comma. You can also specify here the empty characters, so the empty string, then basically they will be joined without any characters in between, like this. Then you get A, B, C, D. Okay, so that's one trick which you will maybe need, and the other one which we already discussed during this lecture is the lower and the upper method of a string, which can basically convert it or create a new string which is the same as before, just everything in lower or in uppercase. And last but not least, you can also chop away white spaces, which is very often very useful if you have deal with user input, because maybe the user will just entering additional white spaces which you don't need. And if I have just a word and I can say just split, then basically from the left and the right hand side, sorry, not split, that's not what I wanted to do, but strip, then from both sides basically the white spaces are chopped off. Or if you want to have only chop them off on one or the other side, L strip would chop off just the left white space but keep everything on the right hand side, and R strip would do the same on the right hand side. And those are basically only chopping off the white spaces at the end and at the beginning. Any white spaces in between will be kept, so basically word and word, for example, and just strip it. Then you see that the white space in between is maintained. It's only just the beginning and the starting and the trailing white spaces which are chopped off. Good. As you can see, with that we basically finished and reached the end of the slides. Basically everything what I wanted to tell you today we covered. And now basically your task would be just to use all the knowledge which you gained here to solve the exercises, which are not very complicated. And I hope that by using the exercises and solving the exercises, you can even deepen your knowledge on container data types in Python. Thanks a lot for your attention, and I hope to see you at the next session. Bye bye, take care.